Hello students, welcome to our today's class. I hope all of you have a very great weekend with your family and friends. Okay, so now let's move towards our today's topics. Before moving to the today's topics, let's revise what we have learned in our last class. So which chapter we are learning? We are in the chapter number 6, that is refraction of light. Okay, so we have learned in our last class about the term that is dispersion of light. So here in dispersion of light, what we have learned, so when the white light, that is a sunlight, from the sun through the air, you all know that there is air over here. Okay, so when the white light coming from the sun through air enters in any refracting medium, so here you can see the refracting medium is what? It is a glass prism. Okay, what it forms? It emerges as a spectrum of 7 colors. Okay, what do you mean by spectrum? That means all the combined colors. So here you can see the 7 different colors which we called as a Vibgyor. Okay, so what is dispersion of light? The separation of light into its component colors while passing through a medium is called as dispersion of light. So here you can see when the sunlight enters into this medium, what happens? The light gets separated or it gets distributed into the 7 different colors. Okay, so this is called as the dispersion of light. Okay, so among 7 colors, which light bends the smallest? That means which light bends the least? That is a red light. Okay, and which light bends the most? That is a violet light. Now we have seen then we have seen a very nice term, that is which light has a maximum wavelength. So do remember this, red light has maximum wavelength and the violet light, last light, this light has a minimum wavelength. Okay, so this term are very important with related to your MCQ types of questions, so do remember. Okay, so this is about a dispersion of light. Then what we have learned? We have learned a very beautiful term, that is rainbow production. Here what happens? When the light ray from the sun enters into the droplet, this is the droplet, what happens? It gets refracted and dispersed. So here you can see this is the light ray. When it gets entered into this droplet, what happens? It gets refracted. So here you can see the bending, that means it gets refracted and dispersed, that means it gets distributed into the different colors. Okay, so then there is internal reflection takes place. So here when the light gets refracted, you can see over here that there internal reflection, which means what? The light again bounces back into the same medium. Okay, here you can see over here, this is called as a internal reflection within the same medium. Okay, so then what happened after that? Once again lights get refracted while coming out of the droplet. Yes, so here you can see the light is refracted. Okay, again you can see over here this bending, that means the refraction takes place. So all this process together produce a rainbow. Okay, okay, so this everything we have learned in our last class. Related to assignment, everyone have to submit their assignment to your regular work. Whenever I will teach something, be ready with your pen and notebook and write down your own notes, prepare your own notes from the tutorial video. Okay, yes, so here we are moving towards our next topic, which is very simple and very small, that is partial and total internal reflection. Here you can see the term reflection. It is reflection, not is refraction. Okay, so we are learning about reflection. Okay, yes, so what is that? Let's first of all let's learn this diagram. Here you can see the air is a first medium. Okay, which medium is this? Air, which means a rarer medium. Okay, and here you can see water. This is the medium number 2, and water is which medium? It is a denser medium. Okay, here the source of light is there, over situated over here. This yellow color you can see, this is called as a light source. Okay, then these are the reflected rays which we are going to see next. Here there are angles, I which means what? Angle of incidence, and R which means what? Angle of reflection. Here we are learning about the term that is reflection. So R is called as what? Angle of reflection. Okay, yes. So let's see. When the light enters a rarer medium from a denser medium, it gets partially reflected. Here you can see there is a source of light, and this is a denser medium. So when the light, you have to see towards this second ray of light. Okay, so when the light enters a rarer medium, this is the rarer medium from the denser medium, so it gets partially reflected. What do you mean by partially reflected? So over here you can see the part of light gets reflected and comes back into the denser medium. Okay, so here you can see this ray, this second ray, it gets reflected and come back within the denser medium. You can see over here this reflection takes place. Whenever a light gets reflected back in the same medium, then what we called as, this term we are called as reflection. So here the reflection of this second light takes place. So the part of light gets reflected and comes back into the same medium, that is a denser medium, as per the laws of reflection. So this is called as what? A partial reflection. Okay, and the rest of the light gets refracted and goes into the rarer medium. You can see over here, this is the light. Okay, half of the light bounces back into the same medium, that is denser medium, and half of the light will goes into the, it gets refracted and goes into the rarer medium. Okay, so when half light gets reflected in the same medium and half light gets refracted within the different medium, that is a rarer medium, then it is called as what? It is called as a partial reflection. Okay, yes, I hope you all are clear with this. Now as the light going from a denser medium to the rarer medium, it bends away from the normal. Yes, this we have seen. So the angle of incidence is what? Angle of incidence is I, that is smaller than the angle of reflection. Okay, not refraction, angle of reflection, that is R. Okay, so if we increase I, if we increase, here you can see the increase in I will take place. Here also this third ray, now this fourth ray, the increase in I will take place. That means if we increase I, that is angle of incidence, R will also gets increases according to the Snell's law, as the refractive index is constant. Okay, so if we increase I, what happened? R will also gets increases, so that we will get a constant term. Okay, and is what? Refractive index is equal to sin I upon sin R is equal to constant. This we have learned in our Snell's law. Okay, so here what happens? For the particular value of I, that is for the particular value of angle of incidence, the value of R becomes equal to 90 degree. Here in the third ray, in this ray, you can see over here R is equal to 90 degree. That means what happens? A ray of light forms 90 degree angle. Okay, so for particular value of I, the value of R will becomes equal to 90 degree, and this, the value of I is called as critical angle. Here this value of I is called as what? Critical angle, that is angle 90 degree. Okay, so for angle of incident larger than the critical angle, the angle of reflection is larger than 90 degree. So you have to remember that that angle of incidence when it is 90 degree, it is called as what? It is called as critical angle. Okay? Yes. So here in this ray, in the last ray, you can see such rays return to the denser medium. Here you can see all of the light is there in the denser medium. You can see over here this last light, it goes up till here and it again reflected into the same medium. None of the light goes above, that is in the rarer medium, and none of the light gets refracted. All the light gets reflected in the same medium. Okay, thus all the light gets reflected back in a denser medium. This is called as what? Total internal reflection. Here in this ray, what we have learned, we have seen that half of the light gets reflected in denser medium and half of the light goes into the rarer medium. But here you can see all the light gets reflected back into the same medium, that is denser medium. So here what happens? Its total internal reflection takes place. Okay? Yes. So we can determine the value of critical angle as follows. So here 1 and 2, n is what? Refractive index. So here you can see the refractive index of medium 1 with respect to medium 2 is equal to what? Sin I upon sin r. So for the total internal reflection, I is equal to what we have learned? I is critical angle. Okay, so here you can see R is equal to what? R is 90 degree. So we are going to put this value over here, sin 90 degree. So what we will get over here? Sin I, only sin I, because sin 90 is what? Sin 90 is equal to 1. So what is the value of this? We will get, that is sin I. Okay? Yes. So this is a very short topic which we have learned today. Here is some homework which I have given, that is you have to mark a correct answer from this 3 MCQ. Okay. So what we have learned today? Today we have learned a very short topic, that is partial and total internal reflection. Okay. Revise the term and do your assignment on time. Okay, thank you.